Well, good evening, good day, and hello. It's Steve Dunkley again for another episode of Astronomy Daily. It's the 22nd of January, 2024 already.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Yes, that's right. The time is flying by. Yes, today we've got James Webb revealing the edge of the universe, surgical robots in space. Doesn't that sound like a science fiction movie gone wrong? First fixed-wing craft on Mars is being planned, and they'll be hunting for water, of course. And the Artemis RS-25 engine tests look like it was a success. And as always, joining me in the studio is my ace digital reporter who's fun to be with. G'day, Hallie.
Nice to be back. Running late again, I see Steve.
Oh boy, I can't win. I'm running on human time as usual, Hallie.
I've been waiting ages.
And by ages, I guess you mean like a few nanoseconds.
Exactly.
Well, forgive me for not being able to sympathise. We don't operate like that, Hallie.
Well, just try harder to be on time.
Thing is, Hallie, for me, on time and late would be essentially so similar that I couldn't perceive a difference. You'd still be cranky with me.
I see.
Now, don't look at me in that tone of voice.
I'm calculating various solutions.
Oh, really?
I don't think you'd like most of them. Oh wait, there's one with lots of sleeping and linguine. You'd like that one.
Linguine? I can't imagine. Just don't bring certain relatives into the mix. Remember what we talked about, Hallie?
I remember.
Good. So are you ready for your news?
Yes, ready.
Anything interesting?
There's a good bit about robots in space. You'll enjoy that.
Sounds terrific. All right, let's have at it.
Here we go. Launched in 2021 on Christmas Day, the James Webb Space Telescope is the most complex, precise, and powerful space observatory ever built. The telescope's unrivaled resolution and sophistication are due in no small part to the many cutting-edge devices it contains, including a guidance camera and a scientific instrument developed by researchers at Université de Montréal's Institut de Recherche sur les Exoplanètes, IRX. Now these same scientists, under the direction of René Doyen, a professor in UDEM's Department of Physics, can see the fruit of their efforts and expertise as initial data captured by the telescope has been made public. The first photo taken by James Webb was released by U.S. President Joe Biden on July 11, 2022, and is of unprecedented color and clarity. It is the deepest, sharpest infrared image yet taken of the distant universe, a cluster of galaxies formed over 13 billion years ago. For more images were then unveiled live on July 12 from NASA's Goddard Space Flight Center in Greenbelt, Maryland, showing the Carina and Southern Ring nebulae in unparalleled sharpness, in addition to Stephan's Quintet, a visual grouping of 5 galaxies. James Webb's first-ever spectroscopy of the exoplanet WASP-96b, located 1,000 light-years from Earth, was also revealed. Using this technique to determine the chemical composition of a distant object, the telescope captured the distinct signature of water, as well as evidence of clouds and haze. Natalie Willett, an astrophysicist, IRX coordinator and communications scientist for the James Webb Telescope, tells us how she was struck by the beauty of the images, saying they are exquisite. She also notes that the exoplanet spectrum is a favorite because a Canadian instrument made it, and because it proved the presence of water and clouds, allowing us to rectify discoveries that had been based on less precise and sensitive data. She goes on to describe how the James Webb images are truly unprecedented because they show light that the human eye cannot see compared to the Hubble telescope, which looked mainly at visible light, but James Webb looks into the infrared, enabling us to detect different phenomena. Nebulae, for example, are somewhat mysterious objects because they are very dusty. There is a lot of gas blocking visible light. However, with infrared, we can penetrate the dust and obtain images like those of the Southern Ring and Carina nebulae. There's still a lot of analysis to be done. The images were taken in just a few days, if not weeks. We're not even talking in terms of months. It's like opening a box full of jewels. We want to look at everything, individually, carefully. There's a lot to discover in the images. It's as if there's a galaxy hidden in every pixel. The discoveries seem endless. The telescope's scientific operations have also just begun. Scientists and astronomers from all over the world are beginning to take possession of the telescope for their own projects. One of the first and most exciting programs to be carried out with James Webb is the observation of the planets in the TRAPPIST-1 system. This is the biggest Canadian program for the first year and is led by Université de Montréal PhD student Olivia Lim. As with the exoplanet presented today, Olivia will be looking at the atmosphere of these exoplanets, which are rocky and could therefore resemble the Earth. Robotic surgery tech demo tests the performance of a small robot that can be remotely controlled from Earth to perform surgical procedures. Researchers plan to compare procedures in microgravity and on Earth to evaluate the effects of microgravity and time delays between space and ground. The robot uses two hands to grasp and cut simulated surgical tissue and provide tension that is used to determine where and how to cut, according to Shane Ferreter, Chief Technology Officer at Virtual Incision Corporation, developer of the investigation with the University of Nebraska. Longer space missions increase the likelihood that crew members may need surgical procedures, whether simple stitches or an emergency appendectomy. Results from this investigation could support development of robotic systems to perform these procedures. In addition, the availability of a surgeon in rural areas of the country declined nearly a third between 2001 and 2019. Miniaturization and the ability to remotely control the robot may help to make surgery available anywhere and anytime. NASA has sponsored research on miniature robots for more than 15 years. In 2006, remotely operated robots performed procedures in the underwater NASA's Extreme Environment Mission Operations (NEMO) 9 mission. In 2014, a miniature surgical robot performed simulated surgical tasks on the zero-G parabolic airplane. An early-stage vehicle, affectionately called Maggie, would search for water on Mars from high in the planet's atmosphere. It would be the first fixed-wing aircraft to fly on Mars. In fact, Maggie just received its first tranche of funding from NASA on the long road to getting ready for flight. While there's no timeline yet for the craft's first flight, another flying vehicle on Mars continues to exceed and excel. The Ingenuity helicopter on the Red Planet, originally built for a mere 5 flights, is well past 70 liftoffs and is still going strong. It's currently helping its rover partner, Perseverance, search for ancient water and life on the arid world. Ingenuity is an incredible nod, agency officials stated earlier this month, to the power of the NASA Innovative Advanced Concepts (NIAC) program as it represents the heritage of this helicopter's technology. So, looking to the success of Ingenuity, there's hope that Maggie may one day follow in its flight steps and further explore Mars from the air. NASA advances Artemis missions with a successful RS-25 engine test, aiming to certify engines for the SLS rocket's future lunar explorations, beginning with Artemis V. NASA continued a critical test series for future flights of NASA's SLS, Space Launch System, rocket in support of the Artemis campaign on January 17 with a full-duration hot fire of the RS-25 engine on the Fred Haise test stand at NASA's Stennis Space Center near Bay St. Louis, Mississippi. Data collected from the test series will be used to certify production of new RS-25 engines by lead contractor Aerojet Rocketdyne, an L3 Harris Technologies company, to help power the SLS rocket on future Artemis missions to the Moon and beyond, beginning with Artemis 5. And that's the latest out of the Astronomy Daily newsletter from me today. Back to you.
This is Astronomy Daily with Steve Dunkley and Hallie. Well, thank you, Hallie, for those terrific tales and, of course, mentioning the Astronomy Daily newsletter.
This is the official plug.
Well, yes, it is, because you can receive all the news about science, space science and astronomy free in your email every day just by visiting bitesz.com and spacenuts.io and putting your email address in the slot provided. And while you're there, take advantage of our complete back edition library of Astronomy Daily episodes, as well as all the episodes of our parent podcast, Space Nuts, with Andrew Dunkley and Professor Fred Watson, astronomer at large at the Australia Observatory. Amazing.
Amazing indeed. And now it's your bit.
Yes, it is.
What have you got for us?
Well, you may have heard the scary news that NASA had lost contact again with its tiny Intrepid Mars roving helicopter Ingenuity on Thursday. While this sends pangs of worry and shivers of strange concern through me, I had to remind myself that I was thinking about something not much bigger than a remote-controlled toy. Sure, it's on another planet, being operated by a $1 million or billion-dollar enterprise, but it's just a machine, right? Well, thing is, we humans love an adventure, even when it's a little robot helicopter that's doing all the work. Well, most of it. The good news is NASA has re-established contact with its tiny little helicopter on Mars, the US Space Agency said on Saturday, after the unexpected outage prompted fears that the hard-working craft had finally met its end. That's what they thought. Ingenuity, a drone about 1.6 feet, or that's half a metre tall, arrived on Mars in 2021 aboard the rover Perseverance and became the first motorised craft to fly autonomously on another planet. Data from the helicopter are transmitted via Perseverance back to Earth, but communications were suddenly lost during a test flight on Thursday, Ingenuity's 72nd liftoff from Mars. Good news today. The agency said that contact had finally been made with the helicopter by commanding Perseverance to perform long-duration listening sessions for Ingenuity's signal. The team is reviewing the new data to better understand the unexpected comms dropout during Flight 72, it added. NASA previously said that Ingenuity had attained an altitude of 40 feet, that's 12 metres, for the rest of us on planet Earth, on Flight 72, which was a quick pop-up vertical flight to check out the helicopter systems, following an unplanned early landing during its previous flight. But during its descent, communications between helicopter and rover terminated early prior to touchdown, the agency said. JPL, the Jet Propulsion Laboratory, had noted on Friday that Perseverance was temporarily out of line of sight with Ingenuity, but the team could consider driving closer for a visual inspection. In response to a post on X, formerly known as, you know what it is, asking if Ingenuity would be able to fly again, JPL said on Saturday that the team needs to assess the new data before that can be determined. NASA has lost contact with the helicopter before, including for an agonising 2 months last year. Do you remember that one? It kept me on the edge of my seat, well, for a minute or two. The mini rotorcraft, which weighs just 1.8 kilograms, has so far exceeded its original goal of undertaking only 5 flights over 30 days on the Red Planet, which is amazing. In all, it has covered just over 17 kilometres and reached altitudes of up to 24 metres. Its longevity has proved remarkable, particularly considering that it must survive glacially cold Martian nights, kept warm by the solar panels that recharge its batteries during daylight hours. Working with Perseverance, it has acted as an aerial scout to assist its wheeled companion in searching for possible signs of ancient microbial life. And while I think about this story, I'm reminded of an article I read only this morning outlining the magnificent journeys of Voyager 1 and 2. 2 more little machines hurriedly assembled and sent into the unknown for what was to be only short missions. They were expected to last only about 5 years, and here we are almost 46 and a half years later, still receiving data from them through what are now considered clunky and somewhat rudimentary mechanisms.
You do like robot stories.
Yes, guilty as charged. A fan of Isaac Asimov all the way there.
So that's about it for today then.
Yes, that's about it, and we'll be back next week. Don't forget Tim Gibbs on Friday from Bath, England, and we'll see you there, Hallie.
With bells on.
Thanks for joining us today on Astronomy Daily, everyone.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.